Hello everyone, I am Dr. Farida binti Abu Bakar. So today I'm going to explain to you how you should answer the class activity question. So in the class activity question, you have two questions altogether, and let's get started with the first question. In the first question, you were asked to calculate the volume that 12.5 gram of carbon dioxide gas will occupy at a temperature of 40 degrees Celsius and pressure of 1.2 atm. So before we proceed with answering this question, the first thing that you need to do is list down all the parameters that is given to you in the question. So you were given the mass of carbon dioxide is equivalent to 12.5 grams. And then you were given the temperature is equivalent to 40 degrees Celsius and the pressure equivalent to 1.2 atm. So the first clue that is given to you in this question is the mass. Once you have the mass, you will be able to calculate the number of mole. Now we are going to calculate the number of mole. So the number of mole for carbon dioxide is equivalent to mass over RMM, which is the relative molar mass. So the mass given to you is 12.5 grams. So you need to divide with the RMM for carbon dioxide. So you shall get this value from the periodic table. So for carbon, it shall be 12.011. While for oxygen, because you have two oxygen over here, so 2 times 15.9994. Right? So you should get 12.5 divided by 44.0098. Therefore, you should get the number of mole for carbon dioxide is equivalent to 0.2840 mole of carbon dioxide. Okay, this is the first half of the question. So now you already converted the mass into number of mole. So all you have is the number of mole and temperature and also pressure. So from here, you can predict which one of the formula that you can use to answer the question. So the answer is the formula for the ideal gas law, which is the PV equivalent to nRT. Okay, another thing that you need to bear in mind is the value of R. So R is a constant value, which is 0.0821. Okay, another thing that is so important about this value is the unit. So the unit shall be in atm, liter divided by mole, Kelvin. From the unit of the R, you need to check again the unit of the given values from the question. So the pressure shall be in atm, so that's okay, and the temperature should be in Kelvin. So you need to make sure that this 40 degrees Celsius should be converted to Kelvin instead of using it as degrees Celsius. So we are going to plug in the value. So pressure is 1.2. The volume is the one that you want to calculate. N is the one you have calculated just now, 0.2840. The value of R is equivalent to 0.0821. And the value of T is 40 degrees Celsius. So you are going to convert it to Kelvin plus 273. So from here, you shall get V equivalent to 7.0 2980 divided by 1.2. Therefore, you should get the volume for carbon dioxide shall be 6.0817 liter. So this is the final answer for the first question. Moving on to question number 2. A scuba diver inhaled a lungful, which is 350 ml of air at a depth of 33 feet, where the pressure is approximately 2.0 atm and the water temperature is 18 degrees Celsius. If the diver holds her breath, what will the same amount of air occupy at sea level where pressure is approximately 1 atm and the temperature is 35 degrees Celsius? If you look closely to the question, most of the parameters are given in the question, which is the pressure, volume, and also the temperature. Therefore, it's easier for you to use the combined gas law equation. So in combined gas law, the formula is P1 V1 over T1 is equivalent to P2 V2 over T2. Right. So in the question, you were given the initial pressure. So the initial pressure is 2.0 atm and the volume is 350 ml. So 350 ml should be converted to liter. So 350 divided by 1000 over. So at first the temperature is 18 degrees Celsius. So 18 degrees Celsius, you need to convert it to Kelvin. So plus 273. So moving on to the final pressure. The final pressure is 1 atm. And the final volume is the thing that you want to calculate. And the final temperature is 35 degrees Celsius. So you need to convert it to Kelvin plus 273. So after you have calculated this one, you should get 0.7 over 291 equivalent to V2 over 308. Therefore, you should get your V2 is equivalent to 0.7409 liter. Since we want it to be in milliliter, because at first the volume given to you is in milliliter, so your V2 is equivalent to 740.894 milliliter. So this is the final answer for the second question.